Welcome back, folks, to Scripting for Linguists. In this episode, I'd like to answer this question. How much faster is Julia when the data types of a dictionary are explicitly specified? In a previous video, linked to above, I looked at Julia and Python and pitted them against each other with a script that finds the collocates of a node word in a large corpus. I'm going to use that exact same script that I used in that previous video because a viewer of that video left some useful comments to that video as well as another video linked to above with the Rust language when I pitted Rust against Julia and Python. Shout out to @GeorgeRogers1166. He left some good comments about trying to make my Julia code faster. And so I was thinking about it and I was thinking, okay, how much faster is it to actually specify the types of a dictionary in Julia? So to do that, we're going to look at our old friend, the Spotify podcast data set, because I have it on my hard drive. It comes in JSON format. I previously wrote a Python script to create text files, and so it's going to rip through almost 40,000 text files. The full data set has almost a billion words, a billion transcribed words. So what we are going to do is look at Julia when I type the dictionary data types and when I don't. In that previous video I mentioned first, I did actually type the dictionaries, but I'm curious to know how much slower it would be if I hadn't done that, right? And here's the Julia documentation page about performance tips, and they talk a lot about types and setting types in here. Okay, so let's jump over to the code. The code is here. This is the same script. The only difference now is I've taken off the types, so I just have an untyped dictionary here. In all the places I use a dictionary, I remove the type. Right there as well, I return a dictionary, but I don't type it anymore on line 47. Okay, and then down here, I also took away the types of the dictionaries, the key and value data types, what I'm referring to there. Same thing here on 64, and that might have been the last one there. Okay, yeah. Good, so I ran this previously before starting the video, and I'm using Julia version 1.10.0, which is the current release at the time of recording. I'm just using one thread. My script was written to do parallel processing, but I'm just using one thread here. Good. And I have it print out the top 5 collocates just to make sure it's doing everything correctly. Let's go ahead and take a look at the results right away. Jump down to the bottom of these 10 trials. So it did 10 iterations or 10 trials, and it kept the amount of time that it took to do each trial. So with no types on the key and value of a dictionary in Julia, we see times of 212 seconds, 238, 347, 454, 227, et cetera, So we get a mean of 275 if we round up, and a median of 248.6. I'm not totally sure why we have these big outliers right there, the 347 and the 454, but the others are right around 4 minutes. 4 minutes would be 240 seconds, right? So that those are the mean and median. We'll look at the median more than the mean because of those big outliers. So 248 seconds would be 4 minutes and 8 seconds, almost 9 seconds. 4 minutes and almost 9 seconds. Good. Then what I did is I actually went ahead and typed. That is, I specify the data type for each of the dictionaries. So the key is a string and the value is an integer. And so I typed those explicitly there. And I'll do that I did that for every last one of these like this. So I return out a dictionary and I give the data types of the key and the value right there. Same thing here, like that. And here as well. And I think that might be the last one. Yeah. And then I saved it and ran it again. And we can look at the results. I did this before the video started. If we come down here, I just again, printed out the results to make sure it's doing the exact same thing. There's no difference between the results. It's simply just a timing, a benchmarking task here. So after 10 iterations, we see the times which are right above 100. We have 102, we have 103, 104, 105, 105, 106, 108, etc. So we have a mean time of 105.5 and a median time of 105.4. So we put those into a spreadsheet, which we have right here. I already put them into a spreadsheet. So again, on row 2 here, we're looking at Julia, one thread, Julia version 1.10.0. Without giving the data types of the key and value in dictionaries, we see a median of 248.6 seconds. So that is 4 minutes and 8.6 seconds. But if we give the data types of the key and value of those dictionaries in Julia, which is not a whole lot of keystrokes there, it's pretty easy to do, we get 105.5, 105.4. And if we compare this median, the median without typed dictionaries, to the median time per run with typed dictionaries, that is 248.6 divided by 105.4, we get a value of 2.4. That is the relative speed of 2.4. So it's 2.4 times slower to not type the key and value in a dictionary in Julia than it is to actually give the type explicitly. That's a big speed up, 2.4 speed up if you type in the key and value data types. Again, it's not, let me just go back to the code real quick. It's not that big of a deal to do so. Right here, you just say dictionary, the key should be a string, and the value should be an integer. Bang. Not a whole lot there. And then down here, I also did the same thing when I returned out a dictionary from a couple functions. So yeah, a 2.4 speed up for not many keystrokes. So to answer the question, how much faster is Julia when the data types of a dictionary are explicitly specified? In my run here on my computer, it's a MacBook Pro 2021 version. I think it has 16 gigabytes of RAM. It is 2.4 times faster to do so on my system. So there you go. It's helpful to type your dictionaries in Julia. Thanks for watching. See you next time.